Hello, we are going to present you a video titled Open Space Vegetation Structure. It is related with the functions of green infrastructures in the model of smart sustainable cities and the physical transition. We will try to show you how to characterize the vegetation structure of an open space component to understand the relationship with the green infrastructure functions. Moreover, the principal open space components are trees. To understand the way of describe green infrastructures and the measurements of the trees are aims of this video. This list of items summarize the aims of the video. At first, we will make a short introduction. Then, we will see the way of the tree data are recorded by the description of its diameter at breadth height, the height of the tree of the base of the living crown, and the crown radius of a tree. Finally, tree spacing and the growing space on parks and streets, and other spatial information should be described the green area. An urban green open space can be characterized in terms of composition, structure, and functions. Composition is characterized by recording the species composition and its contribution related to the total tree population. Structure is usually defined in terms of tree size, canopy cover, and spacing of the trees in streets and parks. For example, in urban areas as the Polytechnic University of Valencia, we may find green areas with different structure composition, from dense to scattered tree canopy over long surface, or tree canopy over paved impervious surface, or maybe different types of impervious squares or sidewalks with tree lines along the street or path. The basic data of the inventory vegetation structure is the tree diameter. It usually measured by the diameter at breast height, the DBH, at 1.3 meters tall, by tapes and forestry calipers. If we use a diameter tape, we should embrace the 3 DBH section with the tape, cross both sides of the tape, and read directly the diameter data. If we use the forestry caliper, we just select the DBH section and fit it to an orthogonal plane to the tree axis. The second inventory basic data of trees is the height of the distance from the bottom to the top of the tree and over the trunk tree axis. The common and more interesting data are the height of the tree, HT, and the height of the tree of the base of the living crown, HCBLC. That means the height to the first living branch. For height measurements, it may use several direct and indirect ways and devices. And the instruments especially designed to measure the tree height is the called hypsometer or height measurer. We may use an ultrasonic device hypsometer that can provide range distance and several heights, just with the use of the transponder that will send the ultrasonic wave back and set reference position of the observer. To measure the tree height, we place the transponder over the tree bark at the breast height section. The observer will walk until a similar distance to the height, and then from this point will connect first with a view to the transponder, and then will be viewed and recorded the height of the tree. To measure the height of the tree to the base of the living crown, we perform it the same way. place the transponder to the DBH section, and finally view and record in a point of the tree trunk placed at the insertion of the first living branch. To establish the crown radius, we may set the projection to 2 final points of the tree diameter of the crown. We may set the final crown projection points with a device as a densitometer that will let us have a vertical view of the end of the crown. We have to measure the distance to the trunk. Finally, we may need to describe the distance between trees on a line set or on a surrounding area of a street of a park plantation. With the measure set in the first tree and facing to the transponder set on the bark of the next tree, we may measure the real distance or the horizontal distance by the rangefinder. Other spatial parameters could be measured to complete green infrastructure space description, as planting pattern, tree canopy closure along and across the street, and also the possibility to record a cross-section sketch of each open space. Finally, we just have the conclusions. In order to describe the green infrastructure diversity, not only the species composition, but also vegetation structure should be measured and characterized. Vegetation structure is usually defined in terms of tree size, canopy cover, and spacing of trees in streets and parks. The tree structure on a green areas have to be described through individual measurements as diameters, height, or spacing of the tree at green areas, cross sections, or along the streets.